was waiting for the recording. I didn't know if you wanted to record all those or not. Right. If you have, welcome everybody. If you have any topics, you can add it to the agenda. Uh, so we were talking about data ingestion in past weeks, and like it was shared with me that this knowledge is not known to everyone. So I would like to just share the bits. If you have any questions, let me know. So how do we do data ingestion in Thoth? There are, I should have prepared a slide, but I haven't, but I'll go through it technically. So we do all our data ingestion on stage cluster, which you would have known it's called OCP4. You can use your credentials to log in. So each and every one of us should have access to this. It's a access with LDAP group. So you would be in Thoth Ops or Thoth DevOps group. So you should be having a view or edit privileges in this cluster. So we take ingestion, like we have multiple scenarios. There is, so if you would have looked at our architecture diagram from the core repository, you would have known that there is package release, graph refresh, and the package update job and CV update job. These four jobs which creates data for our database. You can go to documents and look for architecture diagram there. I don't know if it will render, but yeah. So this one. Okay, so it renders. So you can see there are these four, these three, and there's one more package update job. So these four generates the data. All of these are cron jobs, which are available in Thoth front-end namespace. They have different scheduling, so they run on their assigned time. I think there will be few runs of that. So they, as you can see, CV update job are completed, graph refresh are just completed, package releases. What they do is they, so if you look at one of them, it captures what packages it needs to schedule for solving and sends a message to Kafka. So it just got gathered all this. It for Python 3.8, UBI 8, it wanted to solve this package UEFI for this version. So it accumulates all that and sends a message, publish the messages to Kafka. So once it goes to the
sorry to interrupt, but sorry to interrupt. A quick question, but does this log show that this single run processed over 6,000 packages?
Where is
like
that?
Because it has 6,000 something lines, and every line is a message, right?
That could be, but there is a filter, I think, in YAML, which basically says how much messages it should send.
Okay.
I think it's an environment variable.
Okay, sorry, actually it was a quick question. Let's not dive into this. Just
so there's a 800 count. That's the messages it will send. Yeah, we can look into the log. So yeah, for if it's sending those many messages. So okay, so messages goes into Kafka. And where is the Kafka? Kafka is also in this cluster. Half of you might have access, not all of you. If you go to a project called AICUE, there is a Kafka deployment. We manage it. There is a Kaf drop deployment. So yeah, thanks to Kevin on most of these things. So he has set up Kaf drop, which is basically a visualization tool where you can view all these, all the messages and things like that. So if you look at this, so there are topics. So we are currently just talking about data ingestion. So there would be from graph refresh, it schedules unresolved. From CV update, it schedules CV update, and package update for package update and releases from there. So let's stick with one. We go through this graph refresh. It will show us how much messages are there. So graph refresh becomes a producer. it produces it. So, and then there is a consumer, which is investigator, which we'll see in a second. So investigator is consuming. So the offset from where it will start to consume next is written here, and it'll try to get to this number. So there are, so whatever is last offset minus first would be the message queue which we have, which is I think somewhere in 900 list. So these are yet to be done. So these are being consumed. So each message will have the information in it, and then there is the investigator, which is an infra namespace. There is this infra investigator. Investigator is the consumer. It will consume all these messages and schedule them for solving. So as you can see, it's scheduled solver for XYZ, and that happens in middle tier namespace. And this is happening at 900, processing 900 messages per hour. So there should be 900 workflows, not 900 pods, but 900 workflows. Each workflow has different steps in it. So there is a solver, graph sync, and send a message back that it has processed this properly. So this is solving. So yeah, Christoph.
Just because out of the resource usage perspective, so if we are scheduling 900 jobs, workflows per hour, most of the hosts of the nodes of the instances are utilized somewhat around 30%. So feels to me like we could increase that 900 to what is it? Maybe 1,200 or so, and utilization will go up, right? That is basically a scaling factor. The 900 messages.
Yeah. So we tend to use all of it.
Here we go.
So that's why it's on that limit of 1,900. Between that number, it plays out, and we tend to keep all our resources busy all the time. If we ask for more memory or CPU, then we can increase that number as well. Okay, so solver finishes the job. It sends the request to Ceph, basically puts the document resultant document into the Ceph. Then there is a graph sync job, which will pick that information and then sync that information from Ceph to database. So that's what is happening. Once the data is in database, then it's being consumed and can be provided to the user. So one question which comes up most of the time is, suppose there are new packages and I want to schedule them, I want it now. You can go to management API and do Python solver. Yeah. So you can ingest that data by clicking on this number. It will send you a solver ID. Once you get the solver ID, you can check the status of it, but technically it will have to wait because it will be pushed into a queue. So it's not something which will happen, but this could be something which we were discussing with priority and things like that. We can change. But as of now, it will go into the queue. It has to wait for that wait period of investigator consuming all of them by that number and then get to that message. So there is this wait time. We don't have an estimate of sharing what's the wait time is as of now. We don't have a metric for that. We have a metric of saying how much do we consume or how much do we clear out in a day. So that's what we are trying to do. And once you have all your things ingested and you just want to check if your package is ingested or not, you can just check your package here. If the information is gathered by the database, then user API can show you that detail. So any questions?
Yeah, there is a question I had while working on storages and stuff like that. Why exactly do we have a two-stage ingestion? I mean, the graph sync. Why do we keep it separate from the first step?
So why don't we have it directly in solver?
Yeah.
I think the reason behind that was to have the solver run explicitly. So if if the solver has completed the documentation, we don't, and somewhere the sync is failing with the database, then then we don't lose that processed result, because we want to also save the computation cost. That's why we wanted to solve the documents. At least if there was a breakage or bottleneck inside the database, then we can still wait for the fix of that bottleneck and then just sync the gathered knowledge, right? Instead of running the whole solver again. Solver is like it is checking for all the metadata and the information of pulling the packages and looking into it. So it was a calculated on based on computation how much we want to reduce the computation. That was the reasoning behind it. We can definitely have it, but then we have to say that our system is strong enough that it will not break on those steps.
So it's kind of a checkpoint.
It's from my point of view, it's a data management topic, right? If we have outdated distributions, like Fedora is out of life, all that data does not need to be in the database itself, in the Postgres database. But I wouldn't throw away all the JSON that we generated at some point in time, right? The information itself might be valuable. Not that we are analyzing that data, but we could go ahead and see how packages evolve with different distributions, for example. If we figure out that problems get solved easier on a RHEL 9 system, or faster actually, on a RHEL 9 system than on a RHEL 8 system, that might indicate something. So the idea was always to, whatever we generate, we're going to keep it basically forever. That is why we have these JSON files around. And whatever we need to answer advices, we're going to put in the database. Does that make sense somehow?
So you mean the database and the JSON document do not have the same information?
Not necessarily, right? Right, Harshad?
So they have similar information, but the places where we split or we place it in the database is different. So it will, if you want to gather the information, it will have all the same categories, but the JSON document will have everything inside it. We will split that into different tables for our easy processing on the advisor side.
Okay.
But that's a great question, why we didn't put everything into the solver, but that's the reason we wanted to reduce the computation again and again if we failed on something. Yeah, any other questions, thoughts?
One question, so to complete the cycle, all this happens in stage, and then eventually there is another component, like another step, which is move this to production, right? So the question will be, how does that happen, just to complete the picture, and when?
Maybe a better question, not a better question, what is it? A predecessor question. Why is it happening on stage? Why is it happening on a Red Hat internal OpenShift deployment? My short answer again would be something like, it's resources available to us. We can use them to generate information. We're going to store that information in all the JSON files that we generate on disk. And now I think, Pep, your question comes next. How does it move from here to there, right?
So this question was thought in multiple times during our discussions. So what we came up with, so initially what we were doing or what's happening there is we move the data. So we take the backup of the database and then we move that into production. Like on the maintenance day, we update our database or get it synced with the production database with stage database, so that it has all the knowledge of data sync, whatever data ingested. But again, what we found out was like advisor runs also have data which syncs into the database, so we will lose them because advisor runs happens in production. So then we came up with this solution of having all the documents pushed to the Ceph of production and then syncing everything in. So that in that way, we are not solving anymore. We are just syncing the data and keeping the database up to date. So that's the flow which we are going towards, but that's not the ultimate solution. The As Christoph explained, for time being, we are doing the data ingestion stage. Everything will happen in production once we are ready for that. It's We have to also manage cost, and we have to make sure we are utilizing the resource on a proper amount than what we are supposed to. So that was the decision behind it. We are still doing in staging till we have most of the data ingested. We are all good to go. Then we can say, okay, let's do the rest of the things in production if it's one or two documents. But till then, we don't want to up our cost as a team. So yeah, that's why we are following this method of doing copying the documents to NextF and then syncing again it into that production database.
And this happens weekly?
So the document sync thing happens every day. There is a document sync job which is running, and then the sync job which should sync it. But time to time, because we fall behind, it's not that convenient to gather a million documents. So what we do is after every sprint, at the end of the sprint on a weekend, we copy the database to the production. So after a sprint, you should see the matchup of both of them. That's what we have been doing till now. But this is all temporary, shouldn't be something which will carry forward in the long run. Yeah, if anyone has better solutions, we can also discuss them. It's not that this is the final solution which we are doing. This is a solution which we are trying to use for the time being. So, any other questions? Okay, so as a developer, I will ask few questions and try to answer them, right? So suppose I was given a task to work on solvers. How do I test them? How do I see if it's working properly? You can always work on your test cluster or the one which we all have. I think my PC is a little slow today, but if you, I'll show you here. So you can always go to your OCP4. You can log in there. Don't look at my password. And you can go switch to the .test core. That's the project which is that's the namespace which you can use for testing. Most of the things are deployed there, so you can definitely mess with it, delete things, and then it can be bought back. So here, I will also show the same thing in UI, but for now, there are a few commands which you can use. As I said, solver is a workflow. Workflow is an Argo. Argo workflows are a topic that you can read up on. We tend to use that multiple times. So there are a few commands to use to check if your workflows are happening. You can always do OC apply of that workflow, or else you can check if there is any existing workflows with this command. It's OC get workflows. It will show you what are the workflows in that namespace. Technically, there's nothing yet. So let's see if we can trigger something. So like whatever we do normally, we will follow the same procedure. Like if you want to schedule something, you go to solver. So yeah, I'll share this secret later, but I mean, you can see it in Thoth application and then schedule this, right? So let me do that. So I scheduled one, and it shows the solver ID. Once you have this, you can also check here by doing this. It should have a workflow running. So normally, how do you see if it's executing or not? There is a CLI from Argo, which you can install. It's called Argo. And also, you can list workflows with Argo list. It will show the same thing. Then you can do Argo get and that solver ID. It will show you what are the workflows inside it. So each Argo workflow has multiple steps, multiple tasks for us say. So like we were talking about solver, then graph sync and things like that. So you can look onto each thing and check based on that. Then it also provides the pod name, so you can look into this and gather the logs. So that's the another thing. So this is one method. So suppose if you're working on a solver, you can go to the solver repository, make your changes, create an image, go head to the manifest, change that version of image, and OC apply your workflows and try to test things up. So yeah, look at these commands and install them if you don't have them already.
And you could also do something like OC get output YAML solver ID so that you see, OC get workflow dash output YAML solver ID or workflow ID, so that you see the whole YAML of the workflow itself, because there's quite a bunch of configuration environments, variables set, and all that blah 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 blah. And I
Yeah,
guess
you can do it
yeah.
with different commands. There's OC describe as well. You can use those things to just look into the YAML. Also, because you are working, you're testing things up, you can also use OC edit. So this gives you option to edit the YAML itself from the OC command. So like if you want to do those things, you can definitely check those commands out. If you want to just stay on UI, like definitely stay on that. There is a UI for Argo as well. So if you go to the routes, you should see Argo UI. This should show you what are the workflows running and things like that. I know a lot of us used to use it in the team. So if you are more of the UI person, use them. Based on your access, you might see some errors and things like that, but you can always go back to your namespace which you want to stick to, and it will show you all those information. So yeah, these many are running. It will show you duration things. If you click on it, it will also show you logs and things like that. Right. Any other questions? Okay.
So what happens if that workflow is done? We're gonna have a new file on disk, right? We store the result as a JSON on disk. Then graph refresh happens. Then what else? How do we import into the database? Can't remember. What is the job name? Also graph refresh?
So graph refresh would put the whole information into the database. So then once you have that, you can check everything on user API. If you want to see where is your document, you can use the AWS local command. You can set up things in your local to go to that path. So I can show you where the information stays. So it'll be on solver, and there would be a bunch of documents because you know the pod name or the workflow ID. So you can just paste that and check if it exists in one of them, or you can look for that so you can gather this information.
And on the test environment, all these sync jobs are happening periodically. They are all enabled. So it's basically a matter of observing and waiting until the point where you really can query the user API for the results, right?
Yeah, if you want to simply test if anything is failing, just head to the test environment, schedule it. It should happen instantly because there's nothing which is running on periodically. It's everything instant. So you can test on those things.
question that comes to mind. Maybe it's obvious, but I just realized that if we add a new solver, let's say RHEL 9, Python 3.9, this has an impact on this backlog of solvers that we need to wait, like, because basically every new so like package to be solved will have like an extra solver to run on, right? So that's a 33% increase, like compared to the current workload.
Yeah, that's correct. So every time every time there's a new solver, we can head to there's a config map which you need to update. So this is the config map, and you can head to each one of them, and there would be this solver config map where you'll define what solvers to enable on which cluster. So let me show you for staging. In staging, we have 3 solvers as of now. As soon as we add the UBI 9, there would be a 4th one, and it is a 33% increase. Yeah.
Okay.
Oh, maybe half, 25%. Yeah.
Yeah,
adding a new solver is something.
Sorry.
Pursue.
No, just a comment that we probably should request more quota.
Yeah, exactly. I think we have done that a few times. That exercise of adding a new solver, it always results in an explosion of workflows, obviously, and it always takes a little bit of time, something at the size of a week or 2 or 3.
Yeah, we have a document on how to update solvers. I think you can check that. I think it's here or in the solver repository, one of the places. But yeah, that's the overall flow. We have to wait for it and till it ingests things. There is a metric, if you're not aware, like I showed that last week in the same call, but let me show that again. So there is this dashboard for content metrics. So you can look at all the knowledge content which we have from Thoth. It's already been clicked, but you can click on the drop down and look for it. It'll show you each bit. So how much is for RHEL? How much did we consume for RHEL 8 Python 3.9? It's already 99%. This percentage is with regards to the packages which are in PyPI. So we have already synced this much. If something is missing, that's in that 1%. Similarly for Python 3.4, if you have more, we can add new new panels with that information, and it'll show you that information. Because this is all coming from Prometheus, so you can see this number dropping, but doesn't mean that the unresolved is 0. Honestly, once the next call happens again, the sync will show you a different number. As you can see. Okay, if no other questions, then I guess that's it from my side.
Thank you. That was useful.
I have a question.
Yeah.
You're showing the S3 LS, right? The solvers listening on this from AWS S3. So I have a question. In Ceph, there is a feature called Traders Gateway RGW, which offers a similar service as AWS S3. You guys ever try to integrate that with like pushing the solvers there instead of S3?
I'm not aware of it, so
Oh,
at least
okay.
I haven't tried. But if you think that's something good, you can suggest it. We can start
Yeah, I mean,
using that.
since you were talking about cost effective and everything, right? So Ceph offers a similar services as S3, storing in the objects in the bucket. So yeah, that's why I was just thinking of that.
So this is
Uh,
the Ceph. We are just using the tool AWS to look into it. So the CLI tool which I was using was the AWS one. The data is still in the Ceph backed buckets.
Oh, okay.
which is true for S3 upshift redhat.com, right?
Yeah.
That is Red Hat internal Ceph deployment hosted by the P&T DevOps people. And the for the production environment on AWS, it's really AWS S3 that we are using, I think in London. But yeah, it's always S3. It seems to be the standard interface.
Any other topics to discuss?
Yeah, I was thinking to give a demo.
So would you like to do it today or on Monday on demo call?
Maybe I'll do it today because I couldn't do it last time, so I thought I'll do it.
So shall I stop the recording and start the recording again? Or what do you think is?
Yeah, let's do that. That way we can push it to the sprint demo thing.
Okay. So thanks everyone for joining.